Okay, we're live. Hello, everyone. Hello, let me just make sure everything is good before jumping into it. There is a poll in the chat right now. The poll is, should I name my firstborn son? Should that ever occur? Boom Shakalaka. So his name would be Boom Shakalaka Burns. It was at yes for 53% for a while. Now it's flipped to no. Oh, no, it's dead even. So make sure, if you are in the live stream, make sure you respond to the poll whether I should name my firstborn son Boom Shakalaka. Actually, I have a whole bunch of interesting names for my kids. Just kind of imaginative things, but fun to think about, like Nebuchadnezzar Burns. I think that'd be fun. Balthazar, but most of them are male names. I have a feeling I'm gonna have a lot of sons, but we'll see. So, yeah, it sounds like you guys can hear me and see me just fine. Let me know how the latency is as well. Looks like everything's fine. But just want to, because again, I'm in a different location and it's Wi-Fi. Usually I have direct Ethernet. I just want to make sure that things are good. So. Boomer. Boomer Burns. So hey everyone, welcome to the live stream. We're going to talk about these two satellites that are offline now. There's actually three, but the third one's not offline. It's just, okay, some people actually responding to my question of, yeah, everything's fine. So, no is winning again. Now for the poll, 52% of people are saying no. 48% of you though are wild, wanting me to name my firstborn Boom Shakalaka. It's pretty wild. Of course, we have a wild group here. We're a whole bunch of weirdos here in a good way, in the best way possible. So, Balthazar, yeah, I think that's a pretty cool name. You know, I like these old school names. And Nebuchadnezzar, like, yeah, it's like the biggest wine bottle that they have. Obviously, it's the Egyptian name, but it's like the absolute biggest wine bottle. I feel like there's some power in that name. I also forgot to brush my hair before I went live. I'm sorry. You know, sometimes I just boom, we want to get into it. So, okay. Yeah, way better than Chad. No, I'm not married. There's no ring. There's no girlfriend. This is just an idea, right? At some point, it should happen. We'll see. But it's nowhere in the near future. Okay, rug burns. Or even, well, I could be sun, because, you know, I'm a sun. So, sun burns. All right. I think we're good. Yeah. All right. So let's get started. Let me close this down a little bit. Well, before we do, 820 votes in the poll and 53% are saying no. So can we get Boom Shakalaka Burns to win by the end? But please vote honestly. You know, just because I'm, you know, talking about don't just vote because I'm saying that. Vote honestly. But will Boom Shakalaka Burns win by the end of the live stream? We'll see. Okay. I could change my name to Boom Shakalaka. That is possible. You know, if I change my name, it's understandable. If you name a kid Boom Shakalaka, you know, that could be tough. That could be tough, perhaps. It's increasing. The no is at 54% now. Okay. Anyways. Hey everyone, geophysicist Stefan Burns here. We have a significant update because there is no satellite data coming in from our advanced probes in space at the L1 point. And this is our DSCOVR satellite and also our ACE satellite. And they let us know what's happening with the solar wind. And these satellites were launched back in 1997, I believe, for ACE, and then also for 2015 for DSCOVR. And they effectively give us a heads up as to what type of space weather is headed our way. Well, they're both offline now. So effectively, we're riding blind. We do have our SOHO space weather data, but it's not comprehensive and it's a very old satellite and it's just not the best. So we effectively don't have any real good forecasting ability now to know what's happening. And we are in solar maximum, as many of you know. This is the most active period of the solar cycle. So you get a lot of solar flares, you get a lot of coronal mass ejections, and you get these supercharged solar wind structures, and you get these radiation storms. A whole bunch of things can happen during solar maximum and the descending phase. Now, if these satellites went offline during solar minimum, not the biggest deal in the world. During solar maximum, it's kind of a big deal. Now, will maybe DSCOVR or ACE come back online shortly? That's possible. DSCOVR was offline before for like 6 or 9 months, a long period of time back in the past. It's only been offline for about a month now. DSCOVR's only been off, or ACE has only been offline for a day. DSCOVR's been offline for about a month. So they could, come back online. That's probably the most likely outcome. But as of this moment, we don't have any data from them. And so that is kind of a critical risk when we have these sort of coronal mass ejections launched from the sun headed our way. And there's a lot of critical infrastructure that utilizes that data to understand what the near-Earth space environment is going to look like and whether they need to take certain precautions. So this is especially important too if you have big sunspots on the sun and there's like, let's say, a Carrington class flare potential. So we don't have that right now. Sunspots are actually, they've kind of plummeted down just for the past couple of days. We'll see if they rebound up. But we really don't have that good of idea of what's on the far side either. We have some helioseismic data we'll look at. There are some sunspots on the far side, but super low res because our solar orbiter probe on the far side sun is performing a superior conjunction, which means it's blocked out by the sun. So we don't have that data as well. So right now we're kind of flying blind, which is why I'm making this video. And there's some other stuff to talk about, especially as it relates to Hurricane Erin. It was a category 1, went to a category 5, or super fast rapid intensification. Actually went from a tropical storm to Cat 5 in 25 hours. Now it's down to category 3, but what we've seen over the past 20, 30 years is that 2 rapid intensifications for a cyclone has actually become much more common. So it could be possible for Hurricane Erin to go from Cat 3 to Cat 4 or Cat 5 again, depending on what's happening. And there's quite a bit of evidence suggesting that space weather influences tropospheric weather, and especially those large weather systems like a cyclone. One of the main ways these interactions work is through atmospheric gravity waves. And so we have this coronal hole high-speed stream that's about to hit us, and these generate atmospheric gravity waves in the auroral regions, so the high latitude regions in the northern and southern hemisphere, and those can propagate down all the way to the equator. And when they hit the troposphere, they can trigger instabilities to basically all of a sudden occur, which can then cause that rapid intensification. So we have that also at play right now because Hurricane Erin is expected to kind of curve off the coast of North Atlantic all the way through Thursday and Friday of next week. So that's plenty of time for these atmospheric gravity waves to propagate down and perhaps change the direction, perhaps intensify the storm again. So all that's happening and more. But yeah, DSCOVR and ACE are currently non-operational. DSCOVR was launched February 2015. It's been offline since last month, July 15th in particular. ACE was launched 1997, offline since yesterday. And I don't know why they're offline. Maybe there's some updates out there. I didn't see any press release on it yet, but we may get some info soon. But this sort of electronic failure is possible. I mean, this is an animation video created by NASA, just released last year, like in October or something, because they are launching a new satellite to the L1 Lagrange point. And that is going to cover the same operational duties as DSCOVR and ACE. And they're doing that because the operational lifespan of these are coming to a close. ACE is already well beyond it as far as I know. And this is actually what that new satellite looks like. I just put an X over it to just in general symbolize that our satellites aren't working. But it's kind of like we need it now. So when you get a lot of space weather impacts, a lot of coronal mass ejections passing by these satellites, eventually you're going to have technological problems, hardware failures. It's just, you have shielding, but space weather is a very powerful, energetic, dynamic environment. And so we've seen these sort of failures before. Sometimes they can bring them back online. We don't know if that's going to happen this time. Now, if we look at our sun, here is that coronal hole that's about to hit us with its high-speed stream. And in fact, it looks like that impact is maybe happening right now. We may be in the co-rotating interaction region part of that high-speed stream impact. So what this is, it's an area in the outermost atmosphere of the sun that's deficient in plasma. This is the corona. And it's low density, low temperature, and it's because it has this high-speed stream of solar wind streaming out of it. And because of the way the solar wind spirals out like this, once this coronal hole is in this geo-effective position, that is when that high-speed stream will effectively be sweeping by the Earth. And so at first you get hit with this high-density wall called a co-rotating interaction region, or CIR, or SEER for short, because this high-speed stream will basically continue to pile up on whatever lower velocity structures at the advance of it, and just piles up the density, increasing it more and more and more. And then once that passes, which usually gives you a pretty good jolt geomagnetically here on Earth, then that high-speed stream comes in. And there is a connection between high-speed streams and changes to tropospheric weather, and also to earthquake activity, even perhaps volcanic activity. Though I'm not aware of any research that specifically looks at that connection. But in general, these sort of solar wind structures influence terrestrial geophysics. And the most notable thing that we have happening right now is Hurricane Erin in the Atlantic. So let me pull up a graphic actually showing a high-speed stream so you can see what I'm talking about. Because it's kind of a dynamic structure. I've shown this before a little bit. Let me show again, just for anyone that perhaps is new. This is a graphic I created for a high-speed stream, and yeah, I put myself in front of it. But here it is. We see this coronal hole in the sun. We see this high-speed stream. This will continue basically to propagate out, but it builds up this high-density wall in the front. You can imagine this actually covering the entire high-speed stream as well. So here is the Earth. That is sweeping by first. Afterwards, we get the high-speed stream impact. So let's look at our real-time data that we do have, so we can kind of understand what we have coming. And that is right here. So we're relying on a web page that was basically built or like in 1997 or something, like pre.com. I mean, this is so funny. This is such a basic website, but we're glad it's up. We're glad that it exists. Oh, ACE is back online in the last hour. Okay, well, let me check this out because I just checked like 20 minutes ago and wasn't online. But we were going to go through this. Oh, it looks like it is. Okay, so here's our real-time solar wind. And this is for the past 54 days. So if I go to our series here, let me put it on DSCOVR only to show you that this has been offline for all this time here. So this goes back to, again, July 15th right there. And then if I go to our 7-day view, we'll see it's totally offline. But let's go to ACE because someone just said it's online, and I did see some initial data just come back in. This is our 7 days for ACE. And it looks like they actually repopulated the data that was off for a while. So it looks like they just filled it in. Let's go to our 30-day to see what it says. Okay, it looks like they filled it in, which is good. So ACE is back online. Praise the gods. Praise the Lord. That is a good thing because we have this this co-rotating interaction region coming in. And well, I wanted to still show you this webpage from 1997. This is the data that we were going off of for a while. And I say 1997 as a joke. I don't know when this is built. It just looks old. But this is our solar wind velocity right there, our density, and then some other things. And we see that our velocity dropped a lot, our density went up, then our density has just gone down, our velocity just went up. So it looks kind of like a co-rotating interaction region, but it's hard to say. But it is a pretty big spike in the density. But now apparently ACE is back online. So let's go to our 3-day view and see what it says. So yeah, ACE is kind of showing a bit of a different story, but does look like we are just starting to approach this coronal hole co-rotating interaction region. We haven't had a solar sector boundary crossing yet. So when this flips to this towards negative, that is when we know that we're starting to be in that high-speed stream. And we do see our density starting to go up a little bit here. I mean, barely. Basically, it's been flat across the entire time frame here. But we do see it maybe starting to trend up in the past 24 hours. And our velocity is effectively flat. Even went down to like 300 kilometers per second. Super, super low velocity. And if we go here to our planetary AP, this is our KP index here. We see that our geomagnetic volatility is very low. So we see that it's down at 1. And that's what you see before you get these impacts to come in. It's almost like everything goes super quiet and then boom, there's that impact. So that is good that this is back online, but it'll be interesting to see if we have more failures in the future because both of these spacecraft are reaching near the end of their lifespan. Now, NASA and a lot of these other space agencies have done a good job designing a lot of their stuff. I mean, like the Mars rovers are a great example, you know, still puttering around on the surface of Mars long after they were expected to kind of die out. So they do a great job with that, but I would say they probably need to get some modern instrumentation there. They are already planning on that. That's a good thing. But the sooner, the better on that. Again, we can look at our geomagnetic activity here. Super, super low for the past 24 hours. So it looks like we're just about to get this impact to come in. They expect a G1 storm from this impact. G1, G2, I would say. Because again, if we go back here to our real time, we see that it is very nicely right there in that equatorial zone. And so as a result, we are definitely getting hit by that high-speed stream, whereas some of the other coronal holes like this one, you know, they're kind of more to the south. It's a little bit less likely to give us a very strong hit, but this guy's right in that main zone. In fact, this is the coronal hole that hit us with its high-speed stream just before we had that magnitude 8.8 megaquake. So as it relates to coronal hole high-speed streams and megaquakes, there is a connection between them. The biggest connection is two things. A, continuous loading from coronal hole high-speed streams over a long duration of time. That seems to be important. And B, very low solar wind density seems to be important for kind of pulling these earthquakes out of the earth. So you can't just point at any specific coronal hole and say that is going to give you a megaquake or something like that. But when we have these recurring structures, that seems to be important. And also the size of them and them being transequatorial and having the right characteristics seems to be important. So this is soon going geo-effective. And I don't think the geomagnetic storm from this is going to be all that exciting. I don't expect there to be any, like, let's say, critical loss of infrastructure from this, right? I'm not saying anything like that. I'm looking at this more from a perspective of how is it going to enhance any instabilities that already exist here on Earth. And well, the biggest one is Hurricane Erin here, now a Category 3. and but possibly going to re-strengthen. It's very likely. When we look at hurricane data going from 2000 to 2020, there's an 83% increase that's unfolded as it relates to double rapid intensifications, whereas single rapid intensifications have only become about 2% more likely. But these double rapid intensifications have become much more likely as compared to 1980 to the year 2000. So there does seem to be this increase in hurricane rapid intensification and specifically double rapid intensification. And this is one of the fastest on record, going from tropical storm to a Cat 5 in just 25 hours. Now it is a Category 3. We see it here with our GOES satellite imagery in just basically outside the Caribbean. I mean, it's effectively in there, skirting alongside the north of Puerto Rico and the other islands here, just kind of zooming along. And thankfully, it has not had direct impact on any significant centers yet. But the big concern by a lot of people is where it may go. So here we have our graphic from NOAA. And let's see if I can zoom this in here for you guys. So here we go. So it was a tropical storm, as you can see, kind of generated off near Africa a little bit. And then look how quickly it went from Category 1, and specifically there's Category 1, all the way to 5 right there. Just really quick. Now it's dropped down to a 3. We see the expected path of this going forward. And the colors here I have are for 50 knot wind speed. So the kind of like the extent of that. So this is the path that it's expected to take. But here's the thing, with that coronal hole high-speed stream impact, when that occurs, it's very likely going to generate atmospheric gravity waves, because we see that time and time again. When we get these sort of space weather impacts, you get these atmospheric gravity waves to be generated in the upper part of Earth's atmosphere in like the high latitude regions. So this would be up in the ionosphere, and then they can propagate down into the mesosphere and the stratosphere, in between the thermosphere and the troposphere. So there's kind of a waveguide that exists for these atmospheric gravity waves. And what can happen is that they can propagate all the way down to the equator, and depending on how they're ducted, they can also hit the troposphere. Another interesting thing is that these sort of cyclones also generate atmospheric gravity waves that can reach up to the stratosphere. So we see how cyclones generate very powerful atmospheric gravity waves. We see how space weather impacts can generate very powerful atmospheric gravity waves. And so it shows that there's a resonance between the two of them. And what happens with these atmospheric gravity waves that are generated by space weather is that it makes thunderstorms more likely, tropical storms more likely, increases in wind speed more likely, if they get ducted to the right layers of the atmosphere. And if they're able to go there, then they can enter into that resonance with them. Now, the research on this is super limited because no one's really looked at it multidisciplinary in this sense, or from a holistic standpoint. But if you look at the different pieces of the puzzle, they are all there. And so we just really need more high resolution data, because our current ability to track atmospheric gravity waves in a very granular sense based on satellite measurements in real time does not exist. So for our models, like our real-time models, they put in these parameters, but we don't have real-time data inputs because it's simply too much data for the computers to crunch. That's kind of one of the problems right now. And because modern science is so model driven, that's why there's in general a level of disbelief as it relates to the connection between space weather and tropospheric weather, because people just simply haven't seen the models to prove it, though a model isn't reality. And so reality is doing its thing. We'll eventually catch up to it. So we see that space weather and cyclones both generate atmospheric gravity waves. We see that space weather gravity waves can move all the way down to the equator. These ones can move up to higher levels of the atmosphere, like the stratosphere. And so I would think, therefore, there's probably a connection between them. It's not always going to happen, but This is a category 3 right now. And if it rapidly intensifies again to a category 5 and perhaps deviates in its course because of this new input from the space weather, which is not taken into account with terrestrial weather forecast, hopefully it doesn't go like this or something, but that is possible. We don't know how exactly it's going to move as a result of this new space weather impact coming in. So keep that in mind. But right now, this is the forecast for it according to NOAA. And we can look at the earliest arrival, and that is showing Thursday, 8 p.m. there. But if we look at the most likely arrival, then that is showing Thursday, 8 p.m. for this zone. So it has enough time because we are having this coronal hole high-speed stream co-rotating interaction region impact coming up in probably 24 hours. And so today's Sunday, the 17th of August. And so this is going all the way up to Thursday. So there's time for this to potentially do some things. And if we zoom out, and let's turn this off, there are even some super long range forecasts, which you have to take with a huge grain, you know, a cup of salt, showing it curving even all the way to like the United Kingdom. So we'll just have to see what happens with this category 5 or now category 3 hurricane, whether it has a second rapid intensification or whether it peters out and dies. This is the first hurricane though of hurricane season. It's mid-August. This goes all the way into November. So we're likely to have more hurricanes, and we're likely, well, we're likely to have tropical storms, of course. We're going to have a lot more tropical storms. We're likely to have more hurricanes. We're likely to get more hurricanes that rapidly intensify. We had that last year too. Like for example, Hurricane Milton rapidly intensified, and that was during a geomagnetic storm. So we had this geomagnetic storm. All of a sudden, boom! It just like really got quite a bit bigger. Could have been because of the atmospheric gravity waves. Though you won't really hear anyone talking about that because most people haven't done the research, and there also isn't, again, a holistic viewpoint, multidisciplinary research that has been done connecting this. There are some, but as it relates to tropical cyclones, some of the research that's been done has been looking at extratropical cyclones because those are up in the higher latitude regions. So they're closer to where these space weather impacts are occurring, you know, in the auroral area. But there is evidence suggesting that these atmospheric gravity waves can go all the way down to the equator. If that's the case, then not only is space weather impacting extratropical cyclone activity and for example, what are they called? Like bomb cyclones, and also heavy snowfall and blizzard conditions and thunderstorm activity and rain, all that stuff, anything that's like enhanced weather, it could also be influencing stuff that's happening in the tropics as well. And I think that's very likely. I think that will get proved out with time. So just a quick update for you today. It does appear that our real-time solar wind data is back online. ACE is back online. So we're no longer down 2 satellites. Looks like we're just down 1. They filled in the data here. We don't know what happened, but it could go offline again. So I'm glad it's back online because no, we don't like going blind effectively. That's not good. And I guess also it is important to point out that right now sunspots are very, very low. We can see that here by looking at our latest sunspot intensity gram. And you'll see almost no sunspots on the Earth-facing side. They've all rotated out. So we don't really have a big flare risk right now. There is a potential for coronal mass ejections because those can get launched from a plasma filament or like even a prominence and some of these other factors. But in terms of like a sunspot and a big flare and coronal mass ejection, we don't really have that possibility. Sunspots right now are just under 90. They're maybe like 85 or so. So they've dropped down quite a bit. And if we go here, we can see our, I think it actually might be right here. Our far side imagery shows some sunspots on the far side of the sun. They're kind of a big cluster, and these might be the ones that rotated out about a week ago. So looks like they're still alive and active. So we do have some more coming eventually. We really don't know what's here. Now, we used to have a good idea of what was happening. I wanted to show you this as well, because we had our solar orbiter on the far side, and it is on the far side right now, perfectly on the far side, which actually means it's performing a superior conjunction with the sun. So if we go to our solar orbiter data provided by ESA, you'll see here, until August 23rd, 2025, solar orbiter is going through a superior conjunction and will not be transmitting any data. It'll continue after that date. And that's because it's literally being blocked by the sun. So you can't transmit these signals through the sun. But when it's slightly off angle from that superior conjunction, that perfect 180, then it can, still send the signal by the sun and Earth can receive it. But right now, until the 23rd of August, we don't have any real-time data from solar orbiter. So for example, all this here is from the, the 29th of July. You'll notice the timestamps here, 29th of July. We've been blind as it relates to the far side, other than helioseismic, for about 2 weeks now. So some of these data feeds, which we're privileged to have at times, are offline right now. So this is not accurate for the sunspots. That's already, we already had those rotate through and everything. And then also we had a little bit of an earthquake flurry just recently, just in the past 90 minutes or so. So may as well point it out. These earthquakes in Tunisia just popped off. So we had a 5.1 here, and then also a 4.5 that just followed up afterwards. But if you look at the time here, it looks like we just had a 5.0 in Argentina as well. Kind of like this burst all coming in at once, because look here. It's, let me close this out. We see there, where is it? 1819 Universal Time, 1830, 1835, and then we have 1909, 1911, 1922 Universal Time. So sometimes this will sit stagnant with magnitude 4 and 5s for hours and hours and hours. And we had all those come in basically just in an hour now. So a big burst of earthquake activity, none of them being magnitude 6s or 7s or anything like that, all 4s and 5s, and none of them even beyond magnitude 5.1. But Tunisia's a little interesting right there. So just kind of unusual activity from that, but that does happen. And the ring of fire, you can see, has been lit up. If you go to our 7 days here, we will see an interesting thing that occurred over the past few days, which I've touched on already. But we had this magnitude 6.3 Solomon Islands, and that was on the 14th of August. And then we had this magnitude 4.9, the Australians put as a 5 right there on the 15th. And then we had this magnitude 5.6 there back off to the east. So we had this interesting pinging motion. Whether or not they're related, you can do your research into that, make up your own decisions. But definitely 6.3, 5, and 5.6 in a 2-day sequence effectively. Bing, bing, bing. 2 to 3 day sequence. So I thought that was interesting. And I do think they are connected together. At least they are in time and location. So that's interesting. But if we go here to our 7 day, put our largest magnitude on, you'll see the 6.3, the 6.3, 5.8. So nothing tremendously huge. We still have a ton of earthquakes happening here. A good indication that that was a very big earthquake that hit Kamchatka. And it has been migrating to the southwest. So it has probably put this whole area there in an earthquake shadow. And certainly this zone there is also an earthquake shadow. But I would say that probably Japan, as a result of this big megaquake, is probably more loaded up with energy than it ever has been in recent time, going back to the Great Tohoku earthquake. And then also this area here is now, this zone right there is probably earthquake shadow, and then probably from here over, it's not. So that's important to point out. And we see this is where we had this zone right here is where we had the 7.3 in Alaska on the 14th. and then there was a 6.2 aftershock. We're looking at 30 days significant worldwide. So this earthquake sequence there, we did have that 7.3 there. This also had a 7.4 foreshock before it eventually happened. So this interesting kind of activity with Alaska and also Russia, and also, as you know, societally, we just had Trump and Putin meet in Alaska. So there's this kind of been like this weird resonance between geopolitics and actual Earth dynamics. And this is probably not in that earthquake shadow. I would say this is probably more the earthquake shadow from that big one, and this probably got loaded up more. So it's possible that we get a big one coming out of Alaska soon. We'll see. We don't know, but it would be very interesting because it would match up with the geopolitical energies at this moment in time. We don't discuss that much on the channel, but there are these connections, archetypal connections across multiple fields and domains of reality. So waiting on that coronal hole high-speed stream impact to come in, G1 storming expected from that. One last thing to show you is that we did have some little plasma filaments blast off, kind of an interesting sequence here. Let's check this out. Here we have our 304 angstrom view of the sun, and it is going to play right now. And so this is our coronal hole right there. It doesn't show up that well on 304, but you'll notice kind of a plasma filament blast right over here fairly soon. There it is, and then you'll see one over there, and then you'll see another one right there. So there's this interesting triple sequence that occurred just in the past 48 hours. And there's actually two that have launched from this area. So again, you'll see this one, then that one. Give this a watch. Coming up. Or we just missed it. And then, yeah, so there it is. And then that one, and then you'll see a second one here right at the very end of the video from this zone. There it is. So that area is very dynamic, and you have to look really closely, but you will actually see the plasma filaments that launched off. So they launched from Earth Direct, both of them. See that one right there, right from Earth Direct. The other one too launched from Earth Direct. I checked the chronograph imagery. They did not show up well on the chronograph. So there's no official solar storm forecast for that, but it certainly launched out into the solar wind and will enhance it a little bit, but it'll probably just be a small transient structure that will probably sweep by us and give us a bit of a jolt, but nothing tremendous, I would say. But you will notice these big plasma filaments on the sun here and here. And so just because we don't have sunspots doesn't mean that we can't have a significant solar storm launch. If we get one of these plasma filaments to really do one of these sort of big eruptions, then that could sweep by us and give us quite a jolt geomagnetically. And so that is certainly possible. I'll keep you up to date on all this. Thank you all so much for watching. Again, I've been your host, Stefan Burns. And yeah, if you'd like to stay up to date with what is happening, then please subscribe to the channel. We cover what's happening with the Earth geophysically, geologically, energetically, solar activity, and more. So yeah, thank you all so much. Wishing all of you well. I have merchandise and all organic holistic wellness tea blends and coffee at earthevolution.com/store. I also have all natural leather shoes, sandals, and boots specifically designed for earthing at wildfreeorganic.com/store. Please check that out. They are the best that money can buy. I sell really high quality stuff at fair prices because I know it's important for you all to support our health and wellness and more during these energetically chaotic times. So I'll be back with more as necessary. Thankfully, ACE came back online. We hope it stays online. And yeah, we're waiting on this storm to come in. So G1, maybe G2, we'll see what happens.